Hello friends, today's question. The ends of a stretched wire of length L are fixed at x equals 0 and x equal to L. In one experiment, the displacement of the wire is y1 a sine pi x upon L sine omega t. Energy is E1. And in another experiment, its displacement is y2, which is given as a sine 2 pi x upon L sine 2 omega t, and the energy is E2. Then we have to find out the relationship between E1 and E2. So we are given that there is a stretched wire. Suppose this is the wire. First end is at x is equal to 0 and other end is x is equal to L. So obviously length of the total wire is our L. So we have to find out what will be the respective energies that will be associated with each displacement of the wire. So let us consider the first displacement equation, which is given. So we can say y1 is equal to a sine of pi x upon L sine of omega t. Now this displacement is having two components here. This first component is called as a special part, and the second component is called as a, you can say, vibration part. Okay, so we are particularly interested in vibration part. So we can say, special part. Special part, it is given as sine of pi x upon L. Now it tells us that there is a single half wavelength, not half wavelength but half wave, single half wave along the length L. Okay. So this tells us that there is a single half wave along the length L, along the length L. And the second part, which is our, you can say, sinusoidal part or vibration part, okay, it tells us that the frequency is omega. So let us first of all analyze this part. So from here we can draw another important conclusion, that this single half wave along the length L, it is a characteristic that is associated with the first mode of vibration. Okay, we can say this is the characteristic of first mode of vibration for a string fixed at both ends. Fixed at both ends. And the frequency of, angular frequency of vibration is given as omega. Okay. Having frequency of vibrations omega. So this is from the first part. Now let us discuss the second part, that I can make say second displacement equation, which is given as y2 is equal to a, and we have sine given as 2 pi x upon L multiplied by sine 2 omega t. So this has two half waves along the length of L. So we can see once again the spatial component, spatial part, which is our sine of 2 pi x upon L, which tells us that 2 half waves along the length L. So this is the characteristic of a second mode of vibration. This is characteristics of second mode of vibration, and the frequency of vibration is our you can say 2 omega. Frequency of vibration is our 2 omega. So from here also we can say this omega 1 represent the first, and y2 represent as the first normal mode, and I said wrong, I think. y1 represents the first normal mode and y2 represents the second normal mode, which can also be concluded from here. Now let us come back to the main question: what is the relationship between E1 and E2? Relation between E1 and E2. So energy of a standing wave is proportional to square of the amplitude as well as square of the frequency. Energy of the standing wave is proportional to square of amplitude, so which we can say a square, and square of the frequency, which we can say omega square. Square of frequency omega square. Therefore, for y1 energy is E1, so proportional to a square omega square, and for y2 energy is E2, proportional to a square, and this is 2 omega whole square. So we can find out their ratio. E1 upon E2 will be equal to a square omega square divided by, this will be coming as 4 a square omega square, and it cancels out. This comes as 1 by 4. We can say that our E1, let me write it here only, so we can say from here E2 is equal to 4 times E1. So this is the relationship between the energy E1 and E2. So the options that are given to us, we can see that option number C is the correct one. Option C is correct. So this question was directly based on the formula that our energy is directly proportional to the square of the amplitude as well as the square of the frequency. So we substitute with respect to especially the equation directly, and we get the answer. So this completes the question. Thank you.